Sometimes it's very painful to watch a science fiction film. There's such a willful disregard of any real science that you actually cringe. Like, how could they say that? How could they do that? And you watch a film like Robinson Crusoe on Mars, and most of the time you're thinking, that's a bright guy writing this.
From a historical perspective, this movie sort of falls in between the end of Mercury and the beginning of Gemini. So all America had at the time that this movie was made was a half a dozen one-man orbital and suborbital flights, very few hours of space experience. And the first Gemini two-man spacecraft had not in fact flown yet when this film was made. So in that sense, it sort of acts as a bit of a time capsule of what we thought we knew and thought we understood about spaceflight.
The spacecraft looks like a working spacecraft in most of the shots. It has retro rockets that do what they're supposed to do. The astronauts behave and talk like astronauts.
That'll be okay.
They weren't just playing for a broad audience. They were also playing to what we would today affectionately call the geeks. And as a geek myself, I thank them for that.
You actually see the use of a reaction control system being used correctly in this movie when they are trying to change their trajectory to avoid this large flaming fireball of a meteor that seems to be constantly skipping in and out of the Martian atmosphere. They use reaction control thrusters, little rockets, to steer the thing up and down.
Fire upper retros. Firing upper retros.
Of course, the use of those rockets ends up causing them to go too low into the Martian atmosphere, and then they have to bail out. Just the idea of leaving an orbiting mothership and sending down a lander was a relatively new concept even for NASA. NASA had actually only adopted the idea of having a modular landing system leaving an orbiting mothercraft about 18 months before this movie was released. So it was the hot new thing. It was called Lunar Orbit Rendezvous by NASA. In the movie, you see the lander, and it looks very much like America's two-man Gemini spacecraft, which of course was not equipped to land on anything. But in the movie, you see that they've adapted it. They put 4 landing legs on it. Gemini was in fact looked at as a landing craft. They did consider this at NASA. But rather than putting the legs just on the piece that you see in the movie, they were going to put the legs on another module, which was a descent module that would have sat underneath that. And they were very serious about it. They were going to launch a Gemini with legs on the top of a Saturn V in a program called Lunar Gemini Direct. So the producers had done some homework here, and it was not inconceivable that Gemini could be used as a lander like that. Screenwriter Ib Melchior, who was the fellow who wrote the original draft for this movie, had in fact been one of the writers for episodes of the TV series Men into Space. An extremely dry and factual look at the idea of lunar exploration. There are no monsters in it. You would think by implication that Melchior may have brought that with him to Robinson Crusoe on Mars, but as it turns out, I believe his original draft did in fact include aliens and bug-eyed monsters, and it was director Byron Haskin who voted to have them ousted. Of course, our perception of Mars was driven by Percival Lowell primarily, who was the astronomer at Flagstaff, Arizona, in the late 19th century, writing articles for Atlantic Monthly magazine, wherein he believed that there was a very real possibility of water on Mars and canals on Mars and huge constructs built by Martians.
It was perhaps Percival Lowell's not quite paying attention in Latin class as a youngster, which really got us involved in a tremendous adventure at Mars.
After all, a canal is all about taking water from where it is to where you want it to be. An Italian astronomer, Schiaparelli, looked through his telescope at Mars. He had imperfect lenses, he personally had imperfect vision, and of course there's a turbulent Earth atmosphere in between. And he thought he saw straight lines connecting various points on Mars. He called these canali, which is the Italian word for channel.
Percival Lowell translated that as canals. And he invented this theory that, that there was water being transported, and the seasonal changes on Mars were due to this advanced civilization moving water from the poles. And indeed, it set the stage for Mars being a target of opportunity, a place where we really wanted to explore.
It certainly was not far-fetched at all for Percival Lowell, based on what was known then, to imagine that Mars was a place which could harbor life. Astronomers knew that Mars had many Earth-like characteristics. It has clouds, it has polar ice caps that grow and recede with the seasons. And I think Lowell got the idea that perhaps there was, in fact, an intelligent culture existing on Mars. And he captured the imagination of many, many people in his day. Some of those folks, like Robert Goddard, went on to really have a profound impact on the exploration of space.
Lowell came up with this mythology that immediately was seized upon by the science fiction writers. So it was science feeding science fiction, and there was a real interactivity and a back and forth. There's great, actually, contemporary value in thinking about all of this, because the idea that the environment has got out of control and that the people have to fight and struggle to try and survive when, say, for instance, water is becoming a very scarce commodity. That's the mythology behind the canale, or the canals of Mars. The Mars in Robinson Crusoe on Mars was pretty accurate for the time it was made. We knew that Mars's atmosphere was thin. I don't think we knew how attenuated it really was. The notion that you might be able to spend part of your time with no helmet on the surface of Mars. The notion that somewhere you might find liquid standing water on the surface of Mars, as the Robinson Crusoe on Mars character ultimately does. That was all about right for that time. Now, we were about to get a very rude wake-up call, because the next year, Mariner 4 was going to go to Mars, and we were going to get the first shots of the Martian surface.
Everybody was horrified because Mars looked suspiciously like the moon. It was covered in craters. And I don't think anybody fully anticipated that. We sort of had an idea of how thin the Martian atmosphere was, but we really didn't know that so many craters would be in the photos. So Mariner 4 changed everything the year after this film came out.
Mars is a great Rorschach test. Whenever we've looked at it, we've seen what we wanted to see there. We see the god of war there. We see canals there. And then when we go to get a definitive answer, what happens? Mars will be covered with a dust storm when we send a space probe, an orbiter there. Or when we try and send a lander there, we'll lose the lander and it will disappear. Time and again, in fact, Mars has eluded our ability to actually study it.
About half of the missions that have gone to Mars have failed. It's a tough place to go. It's, you know, you're trying to land on another planet, which is a long ways away. It's you know, a factor of several hundred times further away than the moon. You know, we went to the moon maybe a decade or two earlier than we should have. We really pushed, you know, what we were able to do. There were lots of people, lots of engineers who were very, very relieved that the last 2 or 3 Apollo landings were canceled, because it was a very, very dangerous activity. The exploration of Antarctica was the same way. People went there before there really was technology to get there.
There is no oxygen to speak of on Mars. Proctor, back in the mid-19th century, he had said that, you know, the atmosphere might be so thin that the most you might see in the form of water would be a frost layer coming out onto the surface in the wintertime. And in fact, Proctor's description from the mid-19th century matches the photos that came back from Viking in 1976 almost perfectly. We see 2 solutions to that in the movie. One of them is Manfredi's oxygen pills, which he's brought with him, presumably provided by these aliens. And that idea goes back to 1898 at least. Garrett Serviss, the famous American astronomer, proposed oxygen pills in his book Edison's Conquest of Mars, which was the sequel to War of the Worlds. So oxygen pills was something that had been around for over 60 years when they chose to use it. It was a very convenient plot device to be able to have him breathing on the surface. The other method for him getting his oxygen makes some attempt to explain why there is fire on Mars and yet he can't breathe. It's an interesting idea. The rocks on Mars, he describes them as a kind of coal, a sort of a low-grade coal. The only difference being is that these rocks actually have some kind of oxidizer in the rock itself, which is kind of like solid rocket fuel. There are kinds of rocket fuel that can do that.
Engine ignition and liftoff of the Delta II rocket with the Mars Exploration Rover.
And he then figures out a way to burn the rocks, get oxygen out of them, repressurize his tanks, and keep going until Friday shows up with the oxygen pills. We see him having a swim in a pool right on the surface, and we now know, of course, that that's very, very unlikely to ever happen. The Martian atmosphere is so thin, the climate is such that it's not believed that liquid water can exist on the surface. There are some scientists who disagree with that, and they have some very good evidence to suggest that it's possible, but only in certain places, particularly the deep places on Mars. There's this huge canyon on Mars called the Valles Marineris, which is twice the length of the United States and 10 times wider than the Grand Canyon. But it's deep enough that some scientists believe that the Martian atmospheric pressure at the bottom of that canyon might just be high enough to let ice go into a liquid state before it turns into a gas. The Mars landers that we sent there had a mast which stood about 6 feet up above the surface of where the rover was when it first drove off the lander. And the pressure difference between the top of that mast and the bottom of that mast was so significant that it made a temperature difference. That gives you some idea of just how thin and sensitive the Martian atmosphere is. So if you can imagine a pressure difference, a marked pressure difference with over 6 feet, imagine what the pressure difference might be in the depths of Valles Marineris, which is, you know, thousands of feet deep in places. There had been evidence that there was water on Mars going all the way back to the 18th century. Dominic Maraldi had noticed the polar caps on Mars and had suggested that if there were polar ice caps, that there was probably water there. And it's interesting because when he made those observations, nobody had actually seen the polar ice caps on Earth. So we actually knew more about the ice caps on Mars than we did on Earth.
Mars's polar caps figure in this movie. You're going to make this quest, you're going to try and get to where the frozen water is. A very appealing part of Mars is going to be in and around the polar caps.
The polar ice cap.
Death Valley was a very clever choice as a candidate for a Martian surface. You see images of a sort of terraced polar cap. I'm not sure that they entirely understood that it was ice terraces or sublimation terraces, which is what actually exists on Mars, but it looked suspiciously like these remarkable photographs that came from Mars Global Surveyor 33 years after this movie was made.
The beauty of Haskins's Mars, the beauty of the real Mars too, is that it isn't like the planets in Star Wars. It's not the ice planet of Hoth, or the forest moon of Endor, or the desert world of Tatooine. Mars is a world with a variated geography and different zones of climate, and that actually is probably one of the most significant, realistic things that they do present to us in that film.
The notion that Mars remained geologically active is something that prevailed right through until the late 1960s, when the later Mariners 6, 7, and 9 flew past Mars and got better pictures. One of the things that those pictures revealed in all its glory was a mountain called Mount Olympus, they named it. It's a gigantic volcano on the plains of Tharsis, which stands twice as high as the highest mountain here on Earth. This titanic volcano probably could never have built itself to be so big here on Earth, but the lower gravity on Mars certainly contributed to this cone being able to build up to such a huge height. So Mars was geologically very active at one time in its past. We'd like to know when, and it will mean sending something there to find that out. But in 1964, it was believed to be geologically active still, or could potentially be.
You need a tectonically active, you need a spinning iron core if you're going to get auroras. And what an astonishingly beautiful idea that to add as a little bit of business to the film. It's an intelligent extrapolation that makes sense given what they're saying. There's a lot of interesting technology in the film, and I think one of the most interesting bits is when Paul Mante's character actually assembles a small portable video camera. You know, you don't know what it is that he's building. There's obviously a lens involved. Is he building a big ray gun? What is he up to there? And unlike a lot of science fiction, and indeed unlike what you might have expected if you looked at the movie poster where he's toting a big blaster space ray gun of some sort, this is a film about an astronaut.
It looks very much, in fact, like the RCA television camera that was sent to the moon on Apollo. The idea of actually sending a camera to take pictures of Neil Armstrong taking his first steps was an afterthought, and yet here we have 5 years earlier. These guys had figured enough to put a video camera on board for the crew to use when they're exploring Mars.
We live in a world right now where the big issue is global warming. Do we actually have the ability to change the environment on a large scale? Well, if global warming really is caused by us, the answer is yes. Did we do it deliberately? No, obviously not. Are there circumstances in which we might wish to do it deliberately? Well, maybe not with this planet, but we look next door at Mars and we say to ourselves, you know, if our population keeps growing, or even just so that we don't keep all our eggs in one basket, we probably should have a second home to live on. Do we want to spend all of our time doing what Paul Mante does in Robinson Crusoe on Mars, trying to find oxygen, trying to find water, trying to deal with an atmosphere that's not really breathable for us? We might in fact do deliberately what we maybe have done accidentally here: invoke a greenhouse effect, cause the planet to become warmer, the planet in this case being Mars, which would cause the frozen water in the permafrost to melt. Mars will have oceans again, seas, rivers, lakes, canals perhaps. All of that might be deliberately done as an attempt to make Mars into a second Earth, to make it Earth-like. And there's an actual term for that. It's called terraforming, making a planet more like Earth. There's a school of thought that says that life is not native to planet Earth, that in fact it came here from somewhere else. And it may be in fact that it came here from Mars. This is actually a legitimate scientific cause for speculation here. Mars is constantly pelted by asteroids and meteors, as we are. They slam into the planet and they kick up ejecta. They kick up material. Some of that will be kicked up with enough velocity that it's going to actually reach escape velocity, meaning it's not going to fall back down. It's going to keep going. Large part of it's going to start falling in sunward. Well, we're in the same plane as Mars is, the ecliptic. Some of that stuff will cross our orbit and we will sweep it up. And if rocks can move here, chemistry can move here. That may include biochemistry. We call this notion panspermia, that life gets transmitted from one world to another.
Mars and Earth exchange rocks frequently. We get about one Great Pyramid of Egypt worth of Mars rocks every billion years. You know, for every million metric tons, Mars gets 1,000 metric tons of Earth rocks. If we find biology on Mars, one of the first questions we're going to ask is it similar to the biology on Earth? And if it is, then one has to ask the questions. Are we looking at Earth biology on Mars, or is our home planet Mars? Did we come from Mars? This stuff will never go away until we get there and actually, you know, turn the rocks over and look underneath them, bring them back to our own laboratories and see what's there.
I think there's no doubt that our destiny is in part leaving this planet. We have this wanderlust. We have this insatiable desire to see what's over the next hill. Our next stop in what I think is going to be an ever-expanding outward journey is bound to be Mars. It's beckoned us from the days we lived in caves, and it's going to be our next home. Whether or not Martians exist yet, there will eventually be Martians, and we will be them.